everyone. Today, we're going to talk about tooling. What is tooling? What can we use tools for? What are the different types of tools? And how are we going to use these tools? So without further ado, let's begin. So I also realise I've been a little bit disingenuous in that whilst we are going to talk about tooling in this video, we are mostly going to be covering static analysis tooling as opposed to dynamic. Now, we are going to talk about both of those in this video, and we are going to be defining both of those and discussing them in a very similar context. But the dynamic tooling and the in-the-weeds information about dynamic tooling and the actual tools that we use is going to come in the next video. So, in this video, we are going to cover what is tooling, the differences between static and dynamic tooling, and then we're going to do a bit more of a deep dive into static tooling, setting it up and looking at it in the weeds as to what it is. We are not going to be expected to understand the ins and outs of static tooling by the end of this video, mostly because, I'm not going to lie, this is where stuff starts to get a little bit more complicated. The tools themselves will be fairly self-explanatory and fairly benign to install, or banal, but one of those. But the actual use of these tools is going to get a little bit more complicated, and that's fine. We're going to have a whole separate video, even maybe series, about getting used to the static tooling and the dynamic tooling, but in this context, the static tooling, how we're going to use them, and all the stuff inside them that makes analysis easier. So when we're talking about tooling, it's very difficult to know where to start, to be honest. For the most part, in my opinion, it's best to just show by doing, and then hopefully the theory kind of follows along with the reality as we're going. And the reason we're in a VM that looks like this is because this is my VM. This is the virtual machine that I'm going to be using for pretty much the entirety of the videos going forward, really except for this one. I know I'm in it right now, but for later on in the video, we're going to be switching over to the VirtualBox virtual machine, which is the one we set up last time, just so I can show you how to set up tooling in that environment, such that when we come on to later videos, and we're talking about dynamic tooling or random tooling that we need to just add in, you can do that on your own, hopefully. And if not, you just inquire, and we go from there. Anyway, welcome to the VM, and the reason that we're doing this here like this is because, as I said, looking at tooling and understanding tooling, especially static and dynamic tooling, the easiest way is to just show, rather than spend a lot of time talking in theory with a load of background music and some cool little stock video that I found, which is exciting and fun. But now we can actually begin to look at the tooling and see what it does and how it impacts our analysis. Okay, so what do I want to look at? What do I want to talk about? I want to focus on two very important programs that will define our static analysis experience, which I realize I haven't defined yet, and I've done that on purpose. The reason I haven't defined it is because it's just going to bog down everything, and honestly, if you want to learn about static analysis via definition, just type it in on Google. Or actually, I will leave some descriptions down in the description, some links in the description about where to go to look for kind of definitions on static analysis, and even free resources where you can go and read about static analysis. However, there are two tools, as I mentioned. We've got IDA and we have Ghidra. These two have a long and storied history, which I'm sure we will get into today, but for the most part I just need you to remember IDA and Ghidra. You'll notice one of them looks like a thing and one of them doesn't. There's a reason for that. It's because Ghidra runs in a different way to IDA. They're just two different programs that operate in different ways. IDA is not free, despite the name. In fact, IDA and its paid version, IDA Pro, is the reason I decided to really start making these videos. I don't want to talk or get bogged down too much in IDA Pro as a cost. It is a professional tool. It is used by professional reverse engineers, and therefore it has a professional cost. Now, we talked about the difference between VMware Workstation Pro and VirtualBox, one being free and the other being, I think it was $199. Ghidra is a free tool developed by the National Security Agency of the United States of America. IDA Pro is developed by a private company called Hexrays. The difference is not free and $199. The difference is free and anywhere up to 12,000 pounds, euros, more in dollars and more in Norwegian kroner, where I am currently based. I have just doxed myself. But nevertheless, the difference is very stark. We will not be using IDA Pro unless we are using, well, the IDA free version, which is available. And we'll go on to talk about where to get these tools and how to install them and all of that good stuff. That is coming. I don't really feel the need to do the steps in that way. We're going to look at the tools and what they do first, because that's the best way to define the tool, and then we're going to talk about how to install it. And I will say the installing is the easiest bit. Understanding static analysis and what it does and what it is by far and away the hardest part. So, we're going to attempt to take this. Because but the only reason is because it's easier for me to edit, and the more work I do in my professional life, the more tired I get. And I will say, whilst we're here, I will be probably editing, or having the need to edit less and less, because the video is going to get less and less glamorous as we talk more and more practically about the tooling and how to use it. And then eventually these videos are just going to be me jumping into a tool and us going step by step through a malware. In my VM, I've included 3 files. Now the reason I've done that is because it is going to highlight, hopefully, why we need static tools. Again, I realize I haven't explained static tools at all yet, but we will do, just give it time. Anyway, we've got 3 files here: codedrafts.exe, codedrafts.cpp, and then python.py. Now, when people learn programming, if they haven't done computer science before and they're just starting out, and I've been there too, where I feel like I don't need a career change, but when I feel like my technical knowledge is non-existent and I'd like to learn something, I learn Python. One, because Python is incredibly intuitive, it's also incredibly powerful and is very useful, and indeed we will be using it over the course of whatever videos we end up making. But the thing about Python is it doesn't prepare you for malware analysis in a lot of cases, mostly because malware is written in C++ and C, as well as some other languages too, and we're going to get to those eventually over time. The reason this is important from a static analysis perspective is because if you only learn Python, you take for granted the fact that actually you need anything other than just the tool itself. However, Python is a high-level language and allows the machine, your computer, to interpret the variables, the functions, the language you're giving it. Let me give you an example. I made this just as we were going. Let's edit with Notepad++. And right off the bat, Notepad++ is an incredibly powerful tool. I use it in every day for everything. And again, we'll probably do a whole video on Notepad++ because it's excellent. If you're stuck using Notepad, please stop. Download Notepad++ today. Although please make sure to download an actual Notepad++. I'll put a link in the description below. I realise I say that because at the time of writing there is a lot of what we would call malvertising or malicious advertising going on, with Notepad++ in particular being targeted for malicious advertising. So please just follow the link that I put in the description and just download the tool. It has everything. It allows you to make scripts for different languages. It allows you to change the language if you want to change the language. It even has a dark mode, which we will come on to discover very fast is necessary for me. I cannot function without it. I will always provide the light mode kind of option, but whenever possible, I will be using dark mode. Anyway, what we have here is like an incredibly basic Python. I wouldn't even call it it's just a script. And all it does is it takes two numbers that it's going to ask of us, so input, and then I've made them integers because if you don't make them integers, Python interprets them as strings. And so if let's say you put 9 and 9 in as A and B, you'll end up getting 99 as a result. So what's basically happening is it takes two inputs, it takes them to function 1 then takes A and B, and then it prints them out. It's very simple. In fact, we can do it right now. So we have an enter, let's do 9, and let's do 18. Now, the computer has interpreted python.py into python.exe. You can see that there. And that's cool. That's awesome. In fact, it's excellent because it means we don't have to do anything. We just make the script. And Python is incredibly forgiving and incredibly intuitive. The script is incredibly, it's not just basic, but it's kind of fun as well because you can readily see how you're inputting stuff and how it works. Now, codedrafts.cpp is the python.py equivalent. If I open this up, you can see it kind of resembles partly sort of what the Python script looks like. There's some difference in language just because they're different languages, but ultimately it's kind of doing a similar thing. If we focus on main, we take two numbers that we've already defined. We have a third kind of integer here that we haven't defined yet, and then that number equals function 1 of x and y. So we go to function 1, and then we see we initialize a new integer called result, and then result equals a plus b. So basically what we did with the Python script, but just a little bit different. We've tweaked it slightly to include a second function that takes result a and b, so the result of a and b, the integer of y, and the integer of z, which is b. They do line up. You can kind of see that. Then it basically takes x plus equals y plus z. And then it c out z, or z, sorry, I'm English, z, and then return 0. So basically all this function is doing is it's taking some numbers and returning, the end result of the addition and then the kind of sum of. It's basically the square of, actually, if I think about it, it's the square of the number. Unfortunately, we can't just run it as we did with Python. In fact, the computer is going to tell us, hey buddy, I don't have a thing for this. And that's because C++ is not natively understood by the Windows operating system. You have to what's called compile it. Why have I just wasted all of my time talking about this? Well, when you get given a malware sample, you won't be given the source code, you will be given the exe compiled equivalent of that source code, which is a problem because if I open this up in notepad++, I get this. If I open codedrafts.exe, which is the compiled version of codedrafts.cpp, I'm going to get this, which I don't know if you've been doing this 10 minutes or 10 million years, this doesn't look like anything. And the reason it doesn't look like anything is because this is language that the machine understands. You're not supposed to understand this. So, I've said all that. What happens now? Whilst we don't have any sort of initial starting point for analysing a compiled C++ binary, like codedrafts.exe here, we have the two tools that I mentioned before. Now there are other tools available as well. I should mention Radar 2, Binary Ninja, all of which come with either paid or free services, but we'll be focusing on both either free and Ghidra. However, for the most part, we are going to be focusing on Ghidra. The reason for that is IDA Free is really good at one specific thing, which is doing what IDA Pro does, but you have to be connected to the internet to use the decompiler, which is really where the real main functionality of decompilers like this come from. And that's really where the benefit is. And it can only do 64-bit executables. I realize we haven't talked about 32-bit and 64-bit. As you can kind of see here, there's an allusion to those in these tools here. Again, there will be an incredibly sophisticated theoretical definition of 32 and 64-bit, but I'm going to break it down to how I think about it. 32 as a number is less than 64, and therefore it is not as powerful and takes up less on the computer. Thumbs up. Now obviously I'm being incredibly disingenuous, but for our purposes right now, we don't need to know the ins and outs, the differences between 32-bit and 64. That'll come later when we talk about registries and dynamic analysis mostly, but some in static too. But for now, 32-bit is a smaller number than 64-bit. And so 32-bit just has less. Just less. I'm happy with that definition. I don't care who hates. It's correct. Okay? It's correct. 64. CodeDrafts is a 64-bit executable. Can we tell that from the properties? I'm not sure we can. We might be able to tell from a tool like DetectedEasy. Again, another tool. Super useful. DetectedEasy is a great tool if it ever loads. What? Why aren't you loading? Oh, there you go. I don't know why that took so long. DetectedEasy is a tool that basically tells me things about the binary that I'm looking at. So, can I increase the size of this? Yeah. So we can see PE64, which means Portable Executable 64-bit. Apparently it's VM protected, which is a kind of packer, or protector I should say, which makes reverse engineering a little bit more tricky. I don't think that's true. So there's some mistake there, because I compiled this myself and I don't remember putting VM protect on it. We've got a compiler that we use, and I did definitely use MinGW. And we have a linker too. So I can learn stuff about this binary. There's so much I can do here that I don't need to worry about. I can get the hash of the binary from the different sections and then overall as well. I can look at the strings of the malware if there are any worth noting. Again, when we come on to actually look at analysis of a binary, we'll be talking about strings and quick ways to analyze malware. But for the moment, I'm not seeing anything that stands out here. This all looks like compiler code. But anyway, I can see the strings, which is really useful because it could potentially tell me something useful about the malware, what it's doing, or somewhere to look, because it also gives me the offset, which is the memory address, which is basically, for lack of a better phrase or term, it's where the thing is. It's the map, it's the address, like your home address. This X data string will be here in the binary. So strings, again, all of this stuff we will come on to talk about, imports as well. So we've got some imports here. Now these are really important, and we'll look more at these when we get into the malware or the binary itself in one of the decompilers or our static analysis tools. But following these can be really important, almost integral when doing malware analysis for stuff like quick wins, because they allow the malware to conduct functionality, and without them the malware can't do anything. There are techniques used by a lot of malware nowadays, it's particularly ransomware, but also things like commodity stealers, or even some of the more sophisticated espionage-oriented malware. What are those? They make use of API obfuscators as well. All things we will cover when we get to them. I really just wanted to show DetectedEasy, and I've gone off on a tangent, but we live and we learn. We close all these down, and we just run Ghidra. I'm not going to run IDA, because IDA requires me to be connected to the internet. I might do it in a little bit just to show what IDA can do, but Ghidra is a great introduction and a great first step because it's what we're going to be using most during our time. The best thing about Ghidra that no other decompiler does is it gives us a random fact. A cubic yard of air weighs about 2 pounds. I don't like the about. I feel like about is a bit cheeky. Give me the actual weight. Anyway. We can see I already have a project open called Lazarus. There is no reason why that is. Stop asking questions. We're going to take codedrafts.exe and we're going to move it into Lazarus. It's as simple as that. We're going to click OK. And we're going to let Ghidra kind of munch away. Yum, yum, yum. Oh, I should cut that. I'm not going to cut that. Yeah, so let it do its thing. And we are given some metadata information. And none of that I really care about. So now it's loaded into Ghidra. If for some reason you've downloaded Ghidra and it doesn't look like this, there's a reason for that. It's because I have a custom dark mode set up for Ghidra. My obsession knows no bounds. And also when I load up Ghidra, it's not going to look anything like the standard Ghidra will. I've changed some of the fonts, I've changed the colours, and you'll see what it looks like when we get into it. It says it's not been analysed. Would you like to analyse it? Always yes. There are a bunch of options you can take here. I tend to just leave it as is, but you can explore them. I'll be honest, when you're starting out, please don't touch anything. You're not going to need anything. Let's full screen this. So we can already see whilst it's analysing, we've got a load of stuff here that we can and should talk about. So let's pause it here and then go into the next session, not session, but the next section about what are we looking at here. And we can see it's finished analysing. So let's take a break and I'll put a stock video with some text and we'll go from here. Alrighty, Roo. We're in Ghidra. And I'm not recording. Alright, doing it for real this time. We'll do it live. Except it isn't live. It's just me. But we are going to one take it. Of the like millions of takes that I've done for this video already. Whatever. This is Ghidra. And we have to get quite familiar with Ghidra because we are going to be using it an awful lot. Unless, of course, you have purchased IDA Pro, in which case, congrats to you, buddy. You have a better tool. And it is a better tool. I'm not going to be the person that's like, actually, Ghidra, made by the NSA, great tool. Great tool. It's the best tool I've ever used. We're not going to be saying that. What we are going to be saying is that Ghidra is a functionally amazing tool for the amount of money that we've paid, which is zero. As I've mentioned before, Ghidra will not look like this if you were to install the standard version. I have tweaked it and have amended it so that it suits my needs. It may not work for you, and in fact dark mode does throw some people off. I will, however, be providing my script, or rather template of Ghidra, and I'll put it in the description below. It's actually on my GitHub page, and I will show you how to install that as well, although that is also on the GitHub page. So maybe I won't do that, because I'm already a bit tired. Not of this video, obviously. I'm not tired of doing the video, but I'm worried about the length. We will cover how to install Ghidra and IDA Free as well, but for now, we're in Ghidra, and we're going to do some Ghidra stuff. So on the right, you have the decompiler, which, as we'll see, is a lot more readable than the assembly we have here. Now, this is assembly. It may not look like much now. I'll show you what it means in a little bit, but this is assembly. And what it does is it has the address of the literal address of where we're looking in memory. It has the hex bytes, which make up the underlying instructions of the malware. You can't really see that here, actually, funnily enough. Let me find a better. We're in the wrong section. Let's go to imports. Let's go to functions, actually, and let's go to, I'm sure main is here somewhere. Oh, well, I'm gonna just search for it anyway. Main. Main's there. Cool. So we're in main, and already, actually, this is a really good way of showing the difference between the assembly section and the decompiler. So as you can see on the left hand side here, we're looking at push, move, sub, call, move, call. Now, this probably doesn't make much sense. We've also got some stuff here, dword, ptr, rbx plus x, oxa, ox14. All of this stuff, if you've never seen it before, looks like sick. It just looks like vomit. And trust me, and there are colleagues who can vouch for this. The first time I saw assembly, I did nearly cry and quit on the spot. So please don't worry about this stuff. We will get on to this, and we are going to talk about assembly, and we are going to talk about what it means and what it does. But the reason I'm doing this section right now, as opposed to doing the theory about assembly language and the theory around why we need a decompiler, is because it's just so much easier to show. So on the right hand side, we actually have the C interpreted equivalent of the assembly. Now, what does that mean? It means that Ghidra, as well as IDA, takes the assembly language, the interpreted assembly, and interprets it into C, which means, it means two things. One, it means it might not always get it right, which is why we have to be not suspicious, but careful of Ghidra and all decompilers, just because, you know, it's just good to take stuff at, not always to take stuff at face value. And this is why dynamic analysis is also really useful to be paired with static. And we'll come on to that as well. I do keep saying we'll come on to that. I do promise we will come on to all these things. I'm just trying to give a basic overview. So we have a call to main here after what's called an assembly or a function prologue. Don't worry about what that means. I'm just trying to clarify that even though it says main here as the first instruction, you can see some instructions prior to that. We're going to do a whole video on assembly prologues and what that means, and when to spot a prologue versus actual meaty assembly. But we can kind of see the correlation between the two, because we have function 1 takes two parameters, 10 and 0x14. Why? That's interesting. It really should. So the hexadecimal is oxa. That's kind of what I wanted, just because it's easy to show here. So you see function 1 takes oxa and ox14. And we can see here, there's like a move. It's putting oxa into rbp plus x. Now x is labeled as such because of x. It's called int x. And then we have 0x14 into y. Now if we remember, I don't know why it's doing that, but if you remember, if I still have it open, x was initialized as 10 and y was initialized as 20. Well, in this case, we can now say that that's for sure. And bear in mind that whilst we're looking at this, we wouldn't have the source code available. We would have to interpret this on our own. So we can say that whatever this variable is, x, is oxa. Now, what is oxa in raw, like decimal, in number? I just keep using the wrong hotkey. Oh boy. Really? Oh, there we go. Convert to an unsigned decimal. Cool. And then same with 0x14, if we can convert that to an unsigned decimal as well. I should be able to change that hotkey so we can actually just do that without having to go through all that faff. And then we can see here, same with Z. It's like Z, we initialized prior to be nothing, and that's why 0x0 is passed in, because it doesn't have any value. Now this is a very basic example, but the principles all stand. That we cannot, the assembly can't lie to us. The assembly is the raw kind of hex of the malware that we're looking at, or the binary we're looking at. And this is where we have to be a little bit careful and just say, is this true? Is this real? let's verify with the assembly, or let's verify with some dynamic analysis. But we have main. So what happens in main? And we can either double click here, or we can double click here. Let's get used to decompiler, because this is what we're going to be using for the majority of everything. So let's click. And we see there's some stuff here that I don't care about. And why don't I care about it? Because it's just initializing stuff. You can see that if not initialized, so exclamation mark equals is like it is not. So if not initialized, and this is using C syntax, not C++, but C syntax, which is why it might look slightly different to our actual script itself. So it's just an initializer. We're going to exit out of that because I don't need it. But this is interesting. We have I_var1 equals function1 10 20. So let's go into function1. And we'll see it looks pretty much identical to our actual function here. Func1, we initialize result. Now the decompiler does that here as well. It initializes the int result, same as we do. It will then do result equals a plus b. Now in this case it's done it that way, and that's just to do with memory, or rather reading of the binary, or rather reading of the assembly, which is fine. And then we have, same as before, we have then func2 takes result a and b. Now you'll see something here, an ampersand, result a b. The reason why that is because func2, Ghidra recognizes from the assembly that func2 actually takes the ampersand x rather than just x. Now what is ampersand? Ampersand is representative of what's called a pointer. We're not going into pointers right now, but I will just say pointers are the address, is a pointer, a literal pointer, like here, over here, to an area of memory that holds the actual value. So rather than x being result, x is actually an address. It's an actual valid address, and we might be able to see that not very clearly, but sort of, because we can see if we just highlight this. You can see there's an add. So it takes local res 10, which is, I think, is B. So you can see local res 10 for B, and then move and then add. No, so local res 10 is actually, that's weird. I think local res 10 is supposed to be A. Actually, there's some confusion there. This is where assembly can get a little bit tricky, but what I can see is like there's a move instruction into EAX. EAX is a register. Please don't worry about any of that. I'm just doing this for my own sakes now. EAX. We're moving local res 10, which I think we can actually rename. Yeah, let's rename it. Local res 10. I'm going to name that as B. I don't know if it's going to have a problem with that. It already exists. B mine. B mine. And then local res 8 equals A mine. So this is a bit weird, because what it does is it takes A mine, moves it into B, and then, oh, okay, no, it does make sense. It makes sense when you relabel it. And this is the power. Wow. This is the power of Ghidra. I'm not editing this out because this is important, and this is kind of a theme of how things are going to go. Sometimes things don't make immediate sense to me until I kind of label them up and take the time to really look at them. Usually what we do is we just look at the decompiler and go, oh, haha, B equals A equals result. Oh, haha. But now we have the ability to take the time to look at the assembly and say, how does this make sense? How does the decompiler make sense as to what we're seeing? And this does make sense, because A, as a value, A is moved into this pointer, PTR equals pointer, by the way, equals here into A mine. Then B, the value, is moved into B mine, which is fine. However, A mine, which is the value of A, is actually moved back into B. And then B mine is moved into EAX, which I said is a register, which is just a place to store values. It's a temporary place for the machine to store stuff. Sometimes it's values, sometimes it's addresses, sometimes I'm trying to think of a joke that's appropriate and doesn't get me banned off YouTube. Sometimes I have nothing for this, and I'm not editing it either. It is always a value, either a memory address or just a simple value, like in this case B mine, although actually in this case it's a memory address. Then B, which is actually A, is added, as you see the instruction here, add is added to EAX. So actually what it's doing is this, because EAX is then moved into result, which makes sense actually. So this is the most long-winded way ever of me explaining how assembly cooperates with our decompiler, and we are going to go into much more detail about this, and we're going to be doing this. I mean, this is static analysis. There's nothing more to static analysis than what we're doing, albeit we will have some more complicated examples, and we're actually going to have malware that's trying to fight against us. But this is it. It doesn't get more complicated than this right here. Well, it gets way more complicated, but the foundations of the principles of static analysis are right here. And I'm so glad I'm not editing this, one, because that would be too easy, but also, well, actually it'd be the opposite, it'd be too hard, but also because it's important for me to state right off the bat, I'm going to be fiddling around with things and making mistakes. And the power of Ghidra allows us to label things, relabel things, get things wrong, redo it, and then get it right eventually. But what I was saying about 5 minutes ago now was we then have func2. And we know that we have func2 because the malware also, func1 also leads to func2. And we were talking briefly about pointers. I don't want to do more than that, than explain at result or ampersand result is actually an address in memory. And we can see that with the LEA, load effective address instruction. What it's doing is it's taking 4 bytes and putting them into RAX, which points to result, which is an address. Don't worry if that makes no sense. It shouldn't. And then now we have the use of the star. Star also just means pointer. Actually, star means dereferenced pointer, actually, when it's been initialized. So using this pointer here, we're able to see that it's actually going to be the value of X rather than, so the value that's at the pointed address. So if you see star used that's on an already initialized pointer, that means a dereferenced pointer. So actually what you're looking at is just the value of result, which is A plus B. If you remember, if we go back, result is just A plus B. So in the same way that we saw before, this is actually kind of a neater way of doing it than we did it ourselves. If we go back to our thing, func2 is X plus equals Y plus Z. Now again, okay, it's not neater. This is actually the neater way of doing it, but we see dereferenced X, so that will be the result, equals dereferenced X plus Z plus Y, which is all this is. And then it just returns the value. And there you go. And then it's going to take the result and it's going to do a load of stuff here that is quite messy. Ghidra has just not really worked out how this thing ends. I actually think this might be a product of the compiler that we used. But ultimately, we've solved out how the malware works without actually having to look at our script at all. Now, as I said, when we look at malware, we won't have this available. We will literally just have ourselves and Ghidra. There are a number of things I touched upon before, which I also kind of want to mention whilst we're in Ghidra. This is going to be our savior, our bread and butter reference point, because we have everything here. We have our classes, namespaces, functions, exports, and imports. Now, I kind of mentioned before imports. we're going to become very familiar with these libraries. Not this one though. That we'll barely ever see. But kernel, it's just because I've compiled it in a funny way. Kernel 32 DLL, MSVCRT.dll, Wininet.dll. These are all DLLs, dynamic link libraries that we're going to become very familiar with over time. And I'm going to say my famous moniker again. We're going to get to it. We are going to get to it. I don't want to bog us down too much in static analysis whilst we're just learning the ropes. I don't want to scare people off. I don't want to try and push people out of this industry already. I want people to take faith in the fact that this may not make sense right now, but it absolutely will do. And in 3, 4, 5 months time, when we've gone through a load of real malware, we can come back to this and go, whatever, dude, this is nothing. And that's what I want. So this is Ghidra. This is going to be our standard tool. I am going to show you IDA, just to show you a comparison between IDA and Ghidra. And I'm going to connect to the internet. I'm going to click that and do some internet stuff. And then we're going to meet back here in about 5 seconds. And we're going to do some IDA. Very basic IDA. Cool. So we're in IDA Pro. As you can see, I've got the internet now turned on, which means we can now view the decompiler, which is kind of, and I'm going to move it here just so it looks like the Ghidra output, kind of exactly the same as what we had before with Ghidra. The one thing I am going to do is I'm going to just change the color to dark mode because I can't function in light mode. Everyone has their own way of doing things. You're just seeing how I operate. The other thing you'll notice is IDA has this kind of different view. If you press spacebar, you'll end up with a very similar view to what we saw in Ghidra. But when there's more than one section of code going on, it'll look like this, where it will show you the options that the execution flow can take based on the value. And you'll see here JZ, which is a jump if 0. There's a load of instructions like this, JNE, JNZ. Again, here we go. I'm going to talk about this later. We're going to talk about this at another point. It's not for now. What I'm doing is actually just showing you IDA. And to, I guess, the uninitiated or to people who aren't used to seeing either IDA or Ghidra, they ostensibly both look terrible. They both look really messy and gross. I agree. But IDA is much more functional. And we can see that really in the decompiler view. Now, if you remember from Ghidra, it didn't actually label Z itself. It had uval1. IDA's underlying mechanics make it a much smoother decompiler to look at, and it just does more work for us. Again, we'll see some of this stuff here that we saw in Ghidra, and it looks to be something to do with the way that it's being interpreted, which is fine. But again, IDA has this really good way of labeling things up, so this looks almost cleaner than our actual script itself, in a way. So if we jump into function 1, again, very similar to Ghidra, but it is just cleaner. And you get what you pay for. As I said, IDA is a professional tool. It is used in a professional setting and environment, and it costs a professional fee. Is it worth it? If you have access to IDA for free, hell yeah, every single day of the week you're using it. But if you don't have the funds to buy IDA, then your second option is this. This is IDA free, and it will only work on 64-bit executables, and you must be connected to the internet. At some point, Hexrays, the company behind IDA, is going to take away this functionality because it is kind of a beta feature that they're testing. What we'll always have is access to the graph view, which may not look very useful now, but certainly when we come to look at actual malware, and looking at execution flow, it's going to be incredibly useful. IDA Pro, I should list all the features that it has, also comes with a debugger, which again won't mean anything if you don't know much about malware analysis, but in the later videos it will make not just a lot of sense, but you will come to appreciate what having a debugger is like in static analysis. It also is really good at analyzing malware for non-Windows operating systems like Linux, so ELF files, Golang, Rust. It's much better than Ghidra is. And because we don't have access to IDA Pro, or we won't have access to IDA Pro, we're going to have to find some interesting and novel ways to get around the lack of IDA problem, and it's totally doable. I will always stand by that it's doable for a hobbyist, and this channel has been made for us to be able to analyze without the need for IDA Pro. I just wanted to show the capabilities of it, and maybe I haven't done it justice, but it is amazing, and it's smooth. And one of the differences between IDA and Ghidra that I guess doesn't get mentioned all that much, and you don't really notice the significance of until you've used both, is that IDA will not attempt to analyze everything at once. If you remember when we looked at Ghidra, we used Ghidra, it said, do you want to analyze? And it will just analyze all of the functions at once, which, whilst sounding like it's a good thing, it can take a very, very long time. Whereas IDA loads the binary, it does do some basic kind of cursory analysis for the decompiler, and just to ensure that, well, it is able to interpret hex code into assembly instructions, but it will only decompile the functions when you step into them, which makes the product just a lot smoother. The underlying engine is just a lot smoother than Ghidra's. And again, you get what you pay for. Ghidra is free and an ever-improving tool. I stand by the NSA on this one and say that Ghidra is the best tool you can use for a hobbyist, unless you're a hobbyist that has just won the lottery. So IDA's great, it's an excellent tool. I'm not going to say a bad thing about it, except for the fact that if you are a hobbyist, it is outside of your price range, as I said, unless you've won the lottery. Ghidra is going to be our friend, and using both static and dynamic analysis together, we can actually enhance the power of Ghidra to be more than just the other static analysis tool. So, with that said, I probably should take everyone through how to install both of these, but in particular Ghidra, because it's not as simple as simply downloading and then executing. There are some things we have to do. It's not complicated, it's just an extra few steps, and let's go do that now. So, here we are in the Google Chrome tab that I have open, and we're going to be downloading Ghidra and IDA. There are other decompilers available. I mentioned Radar 2 and Binary Ninja before. I will put links in the description below for you guys to check those out if you want. I think Binary Ninja is paid, and Radar 2, I have no idea. But they are available and they do work, and you find the poison that fits you best. But for now, we're going to download IDA and Ghidra. We're going to do IDA first because we are. So let's type in IDA free decompiler and see if that what that comes up with. Oh, IDA freeware. There you go. And you see we have access to a cloud-based x86-64 decompiler. We've got a debugger as well, which is kind of cool. That's more for dynamic purposes, which is fine. It's kind of nice. A perpetual license, which is, I'm going to say, a little bit misleading, but it's maybe it isn't actually. You know what? Maybe actually we have this forever. It used to be this was going to be a beta feature, but maybe they've just kept it now forever. Yeah, damn. You know what? I actually take everything I said back about X-rays. This looks like it's not beta anymore. It looks like you can just have this forever, which is great. Damn, that's awesome. because I don't think it used to be like that. I'm pretty sure when I downloaded it, it was very much a tool that was like, oh, we're going to take it away at some point. But here you have all of the versions, depending on what system you're using for analysis. I'm using Windows, and I'm pretty sure you are too, and if you're not, please download any of these. You can see that here. So let's do Ghidra as well, so we can kill 2 birds with 1 stone. Ghidra downloads. Let's see what we get. I mean, come on. Isn't it cool? Isn't it cool? We can download straight from Git. And we have a number of tabs, I would say, or kind of repositories available to us in terms of what to do. We're definitely going to need the installation guide, for sure. So we'll look at that at some point. But for now, I'm just going to download this IDA assets. And I will, once that's downloaded, what I'm going to do is I'm going to put these in my shared folder so we can access the VM. And then I will see you guys in like 5 seconds when I load up my Windows 11 VirtualBox machine. We'll port these in and we'll download them. Excellent. 5 seconds later. Excellent. This is the Windows 11 virtual machine that we've been using. It obviously looks a little bit different to my Hyper VMware Pro Workstation Pro, not hobbyist, genuine Pro virtual machine, but it does ostensibly the same thing. So we've installed Ghidra. Well, we have that's incorrect. We have downloaded Ghidra, and we've downloaded IDA, and we have put them in our shared folder. I have kind of distinguished between malware and tools. I like to do that in my professional life, and if I can pass one thing down to anyone who's listening, is that organization becomes your best friend at times when you don't even realize it. You end up after a while having so many tools and so much malware that it helps to have it organized in some logical format. So have tools, and then I've separated into everyday stuff, which includes things like HXD, WinZip, Notepad++, Python as well, WinRAR, and this will fill up as we go. And then malware analysis stuff, so this is going to be things like packers or unpackers rather, maybe some specific tools, which I think what I've got in here actually. Yeah, so DE4.dot and UPX. So these are both, this is all for unpacking stuff that we will come on to talk about at some point. And then the static and dynamic is where I put the tools. So we've got Ghidra here, and IDA here. Now IDA is as simple as dragging it out into the VM, double clicking oh boy, there we go. Double clicking and going, yep, yes please. Next. Almost saying Ariana Grande just then. Next, and install. And that'll be it. That's actually it. We actually can now just use IDA. I agree. No. Go. And there we go. That's IDA. We can drag and drop as we please, and then obviously options. Colors. Dark. Please. Thank you. There we go. And now Ghidra. Ghidra is the problem child because it's a little bit more complicated. I have taken the liberty. I was about to say I've taken the liberty. I basically just PDF printed the installation guide from the GitHub page, which I will link in the description below. It's all fairly benign and banal. There is... oh no, oh dear. What have I done? It is working, there we go. There's only one thing I haven't done. Or rather, there's only one thing that we actually have to pay attention to in this document, which is this bit here. So it's just this bit, this Java notes, because Ghidra runs on Java, and you need to install the correct version, or a correct version. I think it needs 1.8 or later. I'm going to link in the description the page, the JDK page, which is the Java Development Kit page. So I've got 19 here, which works just fine. Maybe in the future, if you're listening to this in 2037, and the newest Ghidra, which is way better than IDA, which went bankrupt anyway, needs JDK version 55, then you'll have to go download that. But for now, this one works. So we need to take out this from our public folder, or rather our shared folder, and this from our shared folder as well, although my VM is being very unhappy with me. So there's going to be a bit of probably copying and pasting, or rather editing, because we're going to have to be extracting some stuff. So I realized I didn't actually take us through the installation guide. It's because we don't need to do that. So we're going to extract all from the Ghidra, and we're going to put it, you can put it wherever you want, but I like putting it our site. So I think probably program files. And then let's just put it in program files. You know what? Feeling frisky. So continue. So we're just going to install Ghidra. So what we're doing, we're putting all the Ghidra files inside of program files. Now what that means is Ghidra doesn't have a nice GUI installation page like IDA did, where you just click OK and it just vomits into your kind of file directory. You need to extract Ghidra, and then you have to install Java, or rather put Java at a place where the computer can find it, and then Ghidra will run. It's not as, I'm going to use the word sexy, it's not as sexy as IDA in terms of you kind of get you see all of the stuff underneath of how it works, and that can be really cool for some people. But I remember when I first used Ghidra, I was like, what is this? What, this sucks. This program sucks. It actually doesn't suck at all. I'm gonna edit ahead till this hits 100. But after this, we're basically done. We just have to install JDK onto our path, which if you don't know what that means, I'll be honest, I kind of know what that means, and we'll explain it when we get there. So, see you in... I can't do maths. See you in 50%. Oh, damn it. I'll see you in 50%. There we go. So it's here. So we have Ghidra, and the way to run Ghidra is through the batch script file. You can tell it's a batch script file because of the little thingy, the little icon. So let's actually, I don't have Notepad++, that's really annoying. I have it installed on my other VM, but not this one. Can I just, you know what, I can't be bothered, let's just run it. I was just going to see what the underlying process is. I think it literally is just run something. It's run one of these. But as you can see, Java runtime not found, and that's because it literally can't find the Java instance that it needs to boot up the files within its underlying folders. So what we need to do is we need to extract JDK and then add it to path. Path is found at, if you go to your Windows kind of home thing, and you type in environment variables, and you can see that, edit the system environment variables. You can type in anything from this sentence and it should pop up. But essentially, if we have that box and we go to environment variables, you'll see here things on path. Now what path means is that the machine, your Windows machine, can find it at any instance. So, for example, you can see there's PowerShell there. So Windows will always be able to find PowerShell regardless of whether you're in the directory or not. So let's do a really quick example. Command. So if I type Python, well, okay, in that instance, what happens is, because of the way Windows 11 works, if you type Python into the command line, Windows will go, did you mean Python from the Microsoft Store? But actually what it's doing is it's saying, I can't find Python anywhere because I can't find it. So please go get it. However, if I type in PowerShell, you can see PowerShell has loaded. Or rather, I need to type in a PowerShell command, like PowerShell. See, we're in PowerShell, sorry. We're actually in PowerShell. You can see that because the PS. So we're in PowerShell, and you can see that the command line has a color. That's because it's PowerShell. And that's because PowerShell is on path. Same with SSH. SSH is also on path. Which means, again, I can access it from anywhere. Like, if I do a command line from here, now you'll see the command, I deleted the other command line, but you'll see the command line is different. It means that the Windows is now running from this directory. So if I type PowerShell, it will work because it's on path. Again, what I'm trying to kind of insinuate, or rather get to, is that path means that you're showing Windows and your machine where to find the program that you're adding to path, such that it can be accessed from anywhere, which in the context of Ghidra is super useful, because it means Ghidra always has access to the JDK, regardless, the Java development kit, regardless of where you put it on the system. So with that, let's put it in our Ghidra file for no other reason than it's just easy to get to. So let's extract all, and then put it in our Ghidra program files. There you go. And it's going to take a little bit of time, because there's quite a few, it's not going to be that bad, it's not as many as there are with Ghidra. So I'm actually just going to not edit and just keep running. I think I've decided to put classical music in the background of this video. I think so. So I'll let that just play as this is reaching its 100% mark, which is awesome. Cool. So now, without any problems, Ghidra should now just run. Oh, I know why it hasn't run, because we haven't added it to path. So what do we need? Let's just consult the docs. I know what we need, but you know what, it's good practice to always consult the docs where possible. So let's look at our tool. Let's look at our installation guide and see what we need. Okay, so we need to extract the JDK bin. Well, not extract, but copy the bin directory into our path. So let's do that. Sorry, but I should edit that out. Will I? No. So we have JDK, we have bin, so we take this and we Control C to copy, and I think we still have this open. So let me just go back a step. So we're now here. I'm going to go to path. I'm going to click new. I'm going to Control V to copy it, and then I'm going to click OK. And now what should happen is, please, right, there we go, is Ghidra should just run. There you go, it has run. As I said previously at some point in this video, this instance of Ghidra won't look like my version that you were looking at earlier in the video, and that's because I ported in a dark mode script. There is a really quick way for you to do that. As I said, it's on my GitHub page. I'm happy to actually show you like a really quick win way of making Ghidra look like mine without having to install the dark mode. And that is by going to my GitHub page and finding the where are we? I'm going to my GitHub page and finding it should be here, Ghidra. I have a thing called export.tool. So what you can do is you can download that and put it in your shared folder, put it in your virtual machine, and you can go to tools. I thought you could tool options maybe. Tool, please. How do I swear it was as simple as just. Okay, you should in theory be able to import tool. It might be because I don't have an active project. Let's give ourselves a project. Let's analyze IDA in Ghidra. Let's just make a new project. You know what? Non-shared project. Let's call it. There we go. There we go. Now I should be able to, there we go. Okay, that's the problem. You need to create a project. And I'm going to go to my desktop, and then we have export.tool. So now, what should happen is you can see run tool. You want to run code browser 1. So this should work now. Actually, we might not need it. We can just open up Ghidra. Yeah, there we go. Sorry, it took a while. Now you'll see it looks a little bit different because the edges are a bit weird, and the symbol tree is white. Everything's white except for the actual the bit here, and that's because you won't have installed, or rather I haven't installed the actual underlying dark mode of Ghidra, which I will do in another video if there's a demand for it, because you have everything that I have in terms of functionality and color. But if you want like everything to look dark, then we can go through that as well. But downloading tools, and specifically mine, you will get the exact Ghidra look that I have, which is, as far as I'm concerned, is badass. So that is everything for this section. I'll probably do an outro, and then that'll be everything for the static tools, and then we'll actually get to use them at some point, which will be awesome. Cool. And that is actually all from me. I say all, I think the video is quite long now, but I'm not entirely sure how long that is. Anyway, the point is, in this video, what I've tried to do is give an introduction to what static analysis is and how it can be used, and the power. It's basically, it is fundamental. It is literally the cornerstone of reverse engineering. You could, in theory, do reverse engineering with nothing but the static analysis tools. And I wanted to display basically what they look like, and even though we obviously haven't covered how to use them effectively or efficiently, what we have done is showed the two major players. Someone who runs Binary Ninja is going to get very annoyed at me. However, if you want to give me a sponsor, please do. And I will say that Binary Ninja is the only static analysis tool that I've ever used in my entire life. Ghidra, are you? No, never heard of that. But unfortunately, at the moment, with the limited reach that I have, Ghidra and IDA, Ghidra is the best option that we have as hobbyists, and it's an excellent tool. Sorry, I'm trying to caveat what I'm saying. It's a great tool, and I love it. The next session, we're going to be looking at dynamic analysis, which is a soft spot for me, and I prefer it in a way to static analysis. As someone who kind of came into the field knowing absolutely nothing about machines and computers, dynamic analysis is really good as a startup for reverse engineering, because unlike static analysis, when you're looking at malware, dynamic analysis can't lie. So when the program crashes or something happens, we can see exactly what the consequences are of us doing a certain action or following a certain path. When trying to analyze malware, and you want to take it slowly and you want to understand what's going on for kind of life lessons for the next time, it's the best way to go. So I'm really excited about the next session in particular, because that's really where I think we're going to really start to get a grip with basically starting the journey, and I'm super excited. So let's go. Thanks very much for watching, and I will see you guys next time.